Happy New Year everybody and welcome to Bowtie Teacher. In this video I thought I'd take some time to look at the calculator and see how we can utilize all of its functions to the best of our abilities in order to gain the most marks in the GCSE and IGCSE for mathematics. So let's get started. So as you can see from this list, I've tried to pick out the things that I think are the most important that will get you the most marks, and also some things at the end which are really beneficial to save you some time and some accuracy as well. You can see that I've got the FX991EX CLASSWIZ calculator, and that's the one that I would recommend that you would buy before the exam. It's about £20 or 100 dirhams, and it has some things on there that are really going to help you as you move through the test. So let's start with some solving linear equations. So we can use this calculator in a useful way if we have something like, let's say 4x minus 2 equals 2x plus 3, for example. Okay, and we have to solve that equation. So we go about rearranging and all of that stuff, but what we can do on the calculator as well is we can actually solve this using the X button towards the top right. And we type in everything as it is except for the equals sign, which we use the alpha equals button. Okay, so that red one there will put a different type of equals onto your calculator. We'll type in the rest of the equation, and we still don't press equals, we press shift, and then there's a calc button there, so the shift will be the solve. And if it's the first time you've used this, so you'll have an x equals 0 there. That's not the answer, that's just storing the last thing that it searched for. So we're going to put equals this time, and when you do that, you'll see an L minus R equals 0. So it's checking the left hand side and the right hand side and making sure there's no difference between them. And it's given us our x value of 2.5. So if we want to, in the exam, we can use the calculator to check our answer. We can't obviously just put the answer in there, but as we're rearranging this and we take 2 from both sides, and we're in a high pressure situation and we do 3 minus 2 like that, and we work out 2x equals 1 and x equals 1 over 2, okay, what we can do is we can go back to the calculator, check it, and we get x equals 2.5 when we got 0.5, and we're thinking, well, what's going wrong there? And then we can go back and error check our work. So that's something that we can be really using a lot in the exam for the more basic ones, where students drop marks forgetting to take minus signs and things like that. Even the more difficult equations with the brackets, we've got 3 brackets, 2x plus 4 equals, so we're going to use the alpha equals, and let's just put 10 in there. And we press the shift solve, and it's got the 2.5 there from our last answer. We just chuck an equals in there, and it's got minus 0.3, so minus a third. Okay, and students tend to have the negative sign in the question, and they don't expand that out correctly. So this will allow you to check that really well. The next one is quadratic equations. So this is a useful function on the calculator. Let's say we've got something like x squared plus 5x plus 4 equals 0, and we use the quadratic formula and everything like that, but we've got a menu down here which has, we go down to A, that's equation function, press equals, and we want polynomial and degree 2 because it's a quadratic power of 2. And we can just type in the coefficients, that means the numbers in front of the terms. For x squared, which is a 1, the 1 in front of the x is a 5. If it was a minus 5 there, we'd put a minus 5 there, and a 4, and we press equals, and we get x, the first x value is -1, and the next one is -4. So that tells us that the brackets would have to be the opposite of those two values, +1 and x plus 4. Okay, because when we put those brackets equal to 0, then we get x equals -1 and x equals -4. So that will give us the solutions of those quadratic equations. Again, you can start with the answer and work backwards and get the brackets if you like, but just be careful with that. If there's a coefficient of 2 or something like that, sometimes the brackets don't exactly match. So you can use this to check your answers again at the end. Completing the square is something that students kind of struggle with, especially if there's a 2 in front of the x squared or a negative in front of the x squared. But what this calculator can do is it actually does this for us. So let's say we've got x squared plus 6x plus 5, and we have to complete the square on that. So in the test it has something like x plus p squared plus q or something like that. So when we do this, we do the half of the x term, so we get x plus 3 all squared, and then we subtract 3 squared, and then we have the plus 5 that we had originally, and we have x plus 3 squared minus 9 plus 5 is minus 4. So the calculator, if I just do another one of these quadratic equations, so it was x squared plus 6x and 5, and we get the solutions -1, -5, so that would be the brackets would be +1 and +5. But if I go down one more time, it's telling me the minimum of this function, so that's actually the turning point of the graph, which is the completed square version. So you can see here we've got x equals -3. So that is the opposite of this bracket here. That's actually the x coordinate of the minimum point of that graph. And if I press down once more, the -4, that actually gives us the plus q, the y coordinate of this turning point. Okay, so we can actually plot this graph now because we know where its minimum point is at -3, -4 down here. Okay, we know when x equals 0, it's going to go through 5, so we're going to get something that looks like that. Okay, so the completed square version gives us the coordinates -3, -4 of the turning point of the graph. This is for quadratics only, not anything higher than that. Okay, the next one I wanted to show you was simultaneous equations, the linear ones. So if you have something like 3x plus 4y equals 15 and x plus y equals 4, I think. So, you would triple the second one, or you would times the second one by 4 to try and get these equal to each other. But we can also use the same function, this time choosing simultaneous equations, and the number of unknowns for GCSE will always be 2. We can then type in the 3x, the 4y, and the 15, 1x, 1y, and 4. Okay, so when you go through all of that, where you multiply them, you subtract them, and find out x, we get x equals 1 and y equals 3. So we know that at the end we need to have the answers x equals 1 and y equals 3. Okay, and remember, for simultaneous equations, that is the coordinate of the point where both of these graphs intersect. So 1, 3, because the x is 1 and the y is 3. So simultaneous equations, we're using those in this kind of normal standard way, but we're also using that in the sequences and series questions where you have the fourth term is 12 and the sum of the 20 terms is 1,000, and you generate two simultaneous equations there. So in that case, you would have something like 4a plus 9d equals some number, 35, I'm just making these up, and you'd have 2a plus 16d equals 27. With this one, you have to assign a to x and d to y, or vice versa, but keep the same for each one, okay? And make sure you're using the plus sign and the minus sign, making sure that that's correct as well. So you can actually change this for x and change it for y as well. Okay, the next thing I wanted to show you with this is time. Now this is a basic one, but it's something that students really drop a lot of marks for. So you know the type of question where it's saying a plane goes from here to here in 4 hours and 16 minutes. So we can actually turn this into a decimal. So 4 hours, let's do 4 hours and 25 minutes, for example. We're using this button here, which has got a circle, a comma, and then a double quotes there. So I've just done, let's just do that again, 4, and then I press that button for hours, 25, press it again, and it will turn it into minutes. And I press equals, and then the SD button, and, well, I didn't choose very good numbers there, but 4.42 hours. Let's choose a better one here. So 4 hours and 45 minutes. Okay, so that's going to be 4.75 hours. Okay, so a lot of you would be doing the 45 over 60 and things like that, but this calculator will turn it into a decimal for you, and then you can just do your speed equals distance divided by time. Okay, and it works both ways. If you have 1.2 hours, you press equals and then press this time button, and it turns it into 1 hour 12 minutes. So that can be useful for you there. I'm just going to draw the button that you use. It's kind of like a degrees, then this is minutes, and this is seconds. But it looks like a degrees sign, a comma, and a double quotes. Okay, so that's the time button there. Prime factor decomposition, this is when you have a number like 720 and you have to make it in a product if it's prime factors with the cherry trees. We can actually just check this on our calculator. 720, press equals first, and then there's a shift, and you can just see above the button that we just talked about, shift fact. And you can see there it's changed it into powers for us. So 2 to the 4, 3 squared, and a 5. Okay? So you would have to make sure that you did your cherry trees where you broke it down into, you know, the 72 and a 10, 2 and 5, like that. Okay, but you would carry on breaking that down and you would check that you got the right number of 2s, 3s and 5s. So that's kind of useful and it saves you a bit of time there. The next one is tables of values. So this is when you have a table of values with x and y, and it has some function that you need to put on. So let's just say y equals x squared plus 3x plus 2. Okay, and it's got minus 1, 0, 1, 2, like that. So we're going to go to the menu and we're going to go down to table, which is number 9 on this calculator, and we're going to type the function in. So the function is the y equals, the f of x is the same as saying y. So this time we've got x squared plus 3x plus 2. Press equals twice, we don't need a second function here. The starting value is the starting x value, which is negative 1. It's going up to 2, and it's stepping up in ones, so it's going like 1, 1, 1, it's going up in ones. If you have a 0.5 in there, then you can make it step up in 0.5s. And it tells us that minus 1 is going to be 0, so we would fill in minus 1 is 0 there, 0 is 2, 1 is 6, and 2 is 12. Okay, so again, you would do a bit of working out to show how you got these, but you can double check because with the negative ones, students tend to get those wrong when we're using the powers. So the table of values is really useful. We can even use this to do things like sine 2x plus 30. Okay, so sometimes you have later on these trig functions and you have to plot what you think that's going to look like, or you might have to shift the graph like that. You could actually put this in from 0 to 360 and go up in steps of 30 degrees, for example. So as you can see from these results here, you've got your x values 0, 30, 60, 90, and your y values 0.5, 1, 0.5. So you can actually use that to plot your values on your translated or transformed graph. If it's 2 f of x, you can do 2 lots of that as well on this function here. Okay, so you can do 2 sine x as well. That would change that to its correct version there as well. And you can even move them up and down. If you put your plus 1, it's got your new coordinates on there for you. So hopefully that's useful for you to do the tables of values, but also for predicting what your transformed graphs are going to look like later on. Okay, quadratic inequalities. So this is when you have a quadratic graph and it wants to know when it's less than or equal to 0, or where on the graph is it greater than or equal to 0, like that. So let's choose x squared. Let's do minus 4 and minus 3x, like that. So we want to know when that's less than or equal to 0. Okay, so usually you would have to solve this equation, pretend that's a 0 there, so we do our brackets of x minus 4 and x plus 1, and then that would give us our negative 1 here and plus 4 here. Okay, and where is it below the graph? Where is the y value? This is y. Where is that below the y-axis? Well, that's between negative 1 is less than or equal to x and is less than or equal to 4. Okay, So let's just check that on the calculator. We can do menu, we can go to quadratic inequalities. It's a polynomial degree 2 because it's a quadratic. And what we have here is our quadratic, and it's less than or equal to 0. So we're going to use number 4 in this case. And we'll plug in the numbers 1, minus 3, and minus 4. And then we get our answer of minus 1 less than or equal to x, less than or equal to 4. Okay? If that was just a less than sign, then we could just change this to a number 2. Okay? And let's just change it around to a greater than or equal to sign. So when is this above the line? And that is when x is more than 4 or it's less than minus 1. So we have to write that separately as x is less than or equal to negative 1, x is greater than or equal to 4. Let's check that on here. So this one would be number 3 because it's greater than or equal to, and we've got x less there, and it's got a comma to show you that it's got to be separated as well. So you'd have to draw your sketch of this in the exam to show that you understand what's going on, but you've got the answer there to double check for you. Okay, next one, compound interest. So let's say we've got £150,000 and we want to invest it for 4% for 5 years. Okay, so you've got that complicated formula that you can use, but we can also try this. 150,000, press equals, and then I'm going to do answer times 4%. That's 104% of my original investment. So I'm going to do 104%, and then I'm just going to keep pressing equals. That's the first year, second year, third year, fourth year, and fifth year. Okay, so you can also do the 150,000 times 1 plus 4 over 100, and then raise that to the power of number of years and get the same answer. Okay, but some of you might not remember that one in the exam, so you can just work out 4% each time and add that on using the answer button. And for those of you doing GCSE, you can use this for iterations as well. So if you have like UN and then it's UN plus 1 and it does some complicated calculation, you can start with your first number, press equals, and then do 2 times answer plus 1, and it will do that for you. Okay, so the iterations and compound interest are using the same functions on the calculator. Okay, next one, differentiation. So differentiation, you would usually have a function like y equals x cubed plus 2x squared plus 4x plus 1. And the calculator won't actually differentiate this for you, but what it can do is it can tell you what is the gradient at x equals some number. Okay, so if it asks you what the gradient is when x equals 3 for this function, then you would have to differentiate that, substitute your x value into that, and then work all of that out. Let's have a look what the calculator can do for us. There's a d by dx button towards the top right when we press shift, and then there's like a curly s, and it's got a d by dx. Okay, what we're going to type in here is we're going to type in the function x cubed, then we're going to have plus 2x squared plus 4x plus 1. And we want to know what the gradient is at, let's say, x equals 3, I think I said. So x equals 3. I'm going to put that down here in that little tiny box here. Okay, when I press that, we get the answer of 43. So the gradient is 43 when x equals 3. Let's just double check that by differentiating this. dy by dx is 3x squared, so we multiply by 1 and then reduce the power by 1. 2 times 2, reduce the power by 1. This is x to the 1, 1 times 4, x to the 0, excuse me, and then there's a plus 1 which differentiates to 0. So our final function for the differential is 3x squared plus 4x plus 4. Okay, let's substitute x equals 3 into here. So 3 lots of 3 squared plus 4 lots of 3 plus 4. So it's 27 plus 12 is 39 plus 4, yep, that's 43. Okay, so we've double checked our differential when x equals 3. Okay, where else might this be used is when you have a function that, like displacement, and it's in terms of t. Like, let's just say it's t cubed, let's do the exact same one, plus 4t plus 1, and we differentiate that to get the velocity. So velocity is the differential of the displacement, so we're going to get 3t squared plus 4t plus 4, and it says what's the speed, or what's the velocity when t equals 3. Okay, what's the velocity when t equals 3? So you differentiate it and you put t equals 3 into this, but we can just change the t into an x. Okay, let's do x cubed plus 2x squared plus 4x like we just did, plus the 1. We differentiate it at t equals 3, that's x equals 3. Okay, so that's really useful. And if we wanted the acceleration, which is the differential of the velocity, let's say what's the acceleration when t equals 1? Okay, so we would differentiate this 6t plus 4, and then we'd substitute for t, and we get 6 lots of 1 plus 4 is 10 when t equals 1. So let's go through this process so I can show you. We're going to differentiate 3t squared, but we're going to change the t to an x, plus 4tx plus 4, and then we're going to put when t equals 1, and we get 10. So the acceleration would be 10 meters per second squared when t equals 1, but I'm not using t, I'm using x. So I hope that's made that clear to you, but it's really useful for when we're having to find the velocity or the acceleration or the gradient. Okay, an easy one, this one, fractions. Towards the beginning of the test, you'll usually have like a show that question with a fraction, like 4 1/3 plus 2 1/4 equals some number, and then you have to show that. So you will turn that into a top heavy. We can use the shift fraction button and put 4 1/3. Just at the beginning of the test, when you're a little bit nervous, this can be handy for us. It turns it into 13/3 for us. The second one, 2 1/4, okay, and that's 9/4. So just something to ease you in there when you have an easy question. You can use a calculator to turn it into a top heavy. Okay, the next one, sum of a series. I'm just going to put this on another page because we need a bit more space for this. Let's say we have a sequence like 2, 5, 8, 11, and so on. And in the exam, they don't often give you the sequence itself, but what we can do is we can actually use the calculator to check our answers at the end for a question which asks you to sum this up. Let's say they did ask you, so I'll show you the calculator function first and then how we would use this. So this sequence here would go up in 3s each time, and the first term is 2. So a equals 2, and the common difference between each number is 3. So we use our nth term formula, nth term, which is a plus n minus 1d, and we can make this 2 plus n minus 1 times 3, and when we expand that out we get 3n minus 3 plus 2, which is 3n minus 1. Okay, and from key stage 3, like years 7 and 8, you would just say, oh, what's the difference each time, and then you do your 3 times table like that, and then you say, right, I have to subtract 1 each time. So it's the same process, but this is the formula that you actually need to learn, because it says in the examiner's report that students still don't know how to use this formula because it's not in the front of the book. So now that we've got this formula, 3n minus 1, I might be asked in the test to sum the first 10 terms. Okay, so what we would have to do is we would have to add all of these up, and we have a formula for that in the front of the book. They give you this one, which is n over 2 brackets 2a plus n minus 1d, and you would sub all that in and make sure you haven't made any mistakes. But the calculator has a function which is the sum button, which is the shift and the X button. Now it looks a little bit scary, but what I would like you to do is just follow this along and see if you can see what I'm doing here. We've got our formula of 3n minus 1. I'm going to put that in here as 3x minus 1. Okay? And we're going to start with x equals 1. That's the first. We're always going to do that for GCSE. And I want to finish on the first 10 terms. So on the top of this weird squiggly sign, this sigma sign, we're going to put a 10 in here. Okay? And it gives you the answer of 155. So I just use the sum button there, which is just shift and X. Now, let's check this with the actual formula here. So n over 2, it was 10, the first 10 terms, times 2 lots of a, the first term, plus n minus 1, 10 minus 1 lots of the common difference. So we've got 5 times 4 plus 27. So that's 31 times 5. 31 times 5, which is 155. So the sum button has actually checked that for us and made sure that we've got our answer correct. We haven't made any mistakes using this formula in the exam. Okay, so that's quite useful as well. Let's go back to this sum of a series, standard form. Okay, so standard form, I think most people know how to use this on the calculator, but in the examiner's report, it's saying that students are actually getting this question wrong and trying to do it themselves without the use of the calculator. So you can take like 6 times 10 to the 3 and it will convert it into 6,000 for you. So don't forget you're able to use that. But sometimes you're asked to turn 84,000 into standard form. So I'm just going to show you another function here where we've got number format and we can turn it into SCI here. Okay, and we can select the number of digits that we actually want to go up to here. So let's just choose 5. That's the number of decimal places that it's put in here. Sorry, the number of digits that it's put in. So this has turned that into 8.4 times 10 to the power of 4 for us. If we had 1 million, we press equals, it's done 1 times 10 to the power of 6 for us. So sometimes we have these sort of weird numbers that it asks us to turn into standard form, and we're using the scientific mode, the Sci mode, to turn it into a standard form for us. So that's not one that most students use. Once you finish using this mode on your calculator, you must make sure that you put it back. The easiest way is to just do Shift 9 and reset everything, so number 3 and like that. But if you have stuff that you have in your memory that you want to keep, then you can go to Shift Setup, number 3 again, normal, take it back to normal and select number 1. Okay, so that'll put it back where it was. Another calculator function that could be used quite a lot is for rounding to decimal places. The calculator won't round to significant figures for you, unfortunately, but it will do decimal places. So let's do the square root of 27, and we've got 5.196, and it goes on. Okay, we can go to Shift, Setup, number 3, and the Fix mode. Okay, so if we just press number 1 for the fixed mode, and press equals, this will round this to 5.2 for us. So that number 1 told us the number of decimal places that it will round to. If I take it to menu and then number 3, fix and 0, I press equals, it's rounded that to the nearest whole number. Okay, but be careful with that one. It's better to just use it for 1 decimal place. So we're going to put that back to normal, and let's find something like 0.75, and we can then round that to 1 decimal place. So fix 1 decimal place and press equals. It actually goes 0.8 for us. Okay, so if you're going to use the fix mode on your calculator, be careful, because it'll be rounding everything, like you'll do 2 divided by 3 and it will say it's 0.7. So make sure if you're going to use fix that you do setup, number 3, normal. You'll get used to sort of switching between these modes if you choose to use them. So now it'll go back to its full version there. The next topic I want to show you is a bit intricate. So it's use this if you wish, if you're not confident, when you have grouped frequency tables like this, and it has frequency here, the frequency here and the class in here. Sometimes it will have just numbers like 1, 2, 3, or sometimes it will have like 0 less than or equal to the height of something that's less than 10 and things, and you have to find the midpoint. Okay, so regardless of which of these types of questions you have, if you have to find the mean, you can use your calculator to do that. Okay, so I'm just going to show you this, but you may choose not to use this because it's a bit intricate. But we go to menu and number 6, and we just choose number 1. Don't worry about all of the other functions. We're just using number 1 here. And you'll see that you've got an X column here. The first time you use this, you'll just have the 1 column. What we have to do just one time using your calculator, just do this once, is go to Shift, Setup, go down to Statistics, number 3, and turn the frequency on. So we've now got a frequency column here. Okay, so let's just choose some random data like 1, 2, 3, 4, 5, and 6. Let's say we're throwing a dice and we get a frequency and we get like 6 for this one, 8 for this one, 4 for this one, 10 for a 4, 5 for a 5, and 8 for a 6. Okay, so we filled in those 2 columns. It didn't take very long. Once you've pressed all of that data in by pressing the equal sign, we actually press the AC button, which you wouldn't think you do, but you press AC and it takes you to statistics mode, and we're going to press option and then 1 variable calculations, number 2. Okay, so like I say, it looks a little bit scary, but what we're interested in here is the one that's got X and a little bar across the top. So we've got an X bar, and that's actually the mean value for this set of data. Okay, so it's actually calculated the mean for us, 3.58. If we go down a page, we've got N, which is the total frequency. So we had 41 bits of data there. We've got the minimum, the maximum. Q1 and Q3 are the lower quartile and upper quartile, and with median there is number 4. And we've got the maximum value of 6 there. So if I just go back to my data, you can see that 6, 8, 4, 10, so that's 28, 33, 41. So we had that option 1 variable calc. The N value is the total for the frequency. So we've got everything that we need in there, but the most important thing is X bar, which is the mean. And again, we can just come menu number 1, come out of that mode there. If you're not interested in that and you're comfortable with working out means from group frequency, then by all means. If you have 0 to 10, you do actually have to find the midpoint still. Okay, so that's the one that's going to go in the X column for the calculator. You can't put 0 to 10 anywhere. You actually have to put the midpoints in. Okay. Next one, ratios. So we go down to ratios, which is option C, and we have 2 options here for ratios. So where we would use this is, let's just do this on a new page. For ratios is if you have some sort of scale like 1 to 3, or you're using similar shapes, and you have your length scale factor of the first thing to so that, yeah, if you have your triangle like this, 12, and that one goes to 18, you would use the 12 to 18 as a ratio. And it says, well, if this one is, I don't know, 20 centimeters, what's this one here? Then you can actually say, well, 20 is on shape A, so I'm going to put that there. And what's this one here? Well, the calculator's asking you what's A, B, C, and D. So this is A here, this is B, this is C, and this is D. And which one is missing? It's D. So D becomes your X. and that's number 2. If it was going the other way around and it had given you the larger one of the two and said work out the smaller one, then you would choose option number 1 in this case. So we're going to choose option number 2. We've got a 12 to 18 ratio, and C is 20. So X, the missing one, is 30. Okay, so let's just check that. What we'd usually do is we do 18 divided by 12. That's 3 over 2. Okay, so that's a 1.5 scale factor. So 20 times 1.5 is indeed 30. So we can check our answers to these basic ones here, but it's also useful when we're doing our volume ones and we've squared these and we do, square them for the area and we cube them for the volume. All right, so the ratios can be used. Also, there was a question in the last one which was about age, and it said 3 years ago they were in a ratio of 2 to 7, and they're 20 now. How old is the other person, or something like that? So we had to do 15, and it was this. Okay, I think it was something like that. And then, so in this case, this is A, B, C, and D. Let me just label that in case you can't see it very well. A, B, C, and D. So this is X, it's missing one. So this time we're going to do 2 to 7, and then they're 15. So this wasn't the exact numbers, but it's 52.5. So that they're 52.5, and then you add the 5 on because they were saying like, oh, 5 years ago or 3 years ago or something like that. I think it was 3 years ago. But yeah, you would use ratios to help you with that. Okay. 2 more, memory function and substitution. Okay. So in the examiner's report, where the examiners get together and they sort of discuss where students are going wrong, what they're saying is that a lot of you are rounding your answers too early. So rounding too early. So what's happening is if you're doing, say, trigonometry and you've got your angles and you do all your tan and everything like that, you're sort of truncating your answers, like you're doing 4.756 or something like that, and you've got all your answers. Some of you are just putting like 4.7 into your calculator, or 4.8. So what I'd advise you to do is actually use the memory functions on your calculator. So let's do, let's say you get an answer and you do inverse tan of 0.7 or something like that, and you get this 34.9920202 like that. What you can actually do is store that in your memory, and you've got A, B, C, D, E, F in red, X, Y, and M. So there's quite a few slots there for your memory. I'm going to press the store button and put it into slot A, and it says answer has gone into slot A. Okay, so now what I can do is when I'm using that number in my calculations, let's say I have to use that to do another part of the calculation, I can press shift and store, the recall button, and I can actually see that number there in the memory, so I know it's in slot A, but in my test I would probably write a little A to remind me that it's there, and I can actually use this in my calculation. So I can do, like, let's say it's 3A, I can use the red alpha button and A and continue my calculations, and that A will stay in there, and that shift recall, that A is still saved in the memory. So instead of truncating your answers and shortening it too early, you can actually keep that whole number in your memory, because sometimes you use the answer button and then you do another answer and that's lost. So using the memory is really good, and if you want to clear the memory, you can do shift, reset, and clear the memory there, number 2. Alright, that's really useful. Okay, the last thing that we're going to do is substitution. Okay, this is quite a basic one, but I think it's something that could be really helpful to you, because often, you know, they'll have a basic substitution. Let's just say like A plus 3B, and it says like A equals 10 and B equals 2. Okay, let's say they give you a really simple question like that, and you're like, oh, I'm freaking out in the exam. This is just an example. Okay, I can use any letter here. I happen to have an A and a B on my calculator, but if that was X and Y or J and K, it doesn't matter. I can just assign something in my mind to that. Let's say A plus 3B. Okay, and what I can do is if I press the calc button here, calc, and I want to put in A equals 10 equals B equals 2, press equals one more time, I get the answer of 16. So the calculator's done 10 plus 3 lots of 2 and got 16 for me. Now, this is kind of a trivial example for you, but sometimes you might have like a y equals 3x cubed plus 2x squared minus 4x plus 7, like that, and you've differentiated it and you've got your x value and you've got your x value of minus 1. Let's make it a bit more difficult, minus 1.5. And you have to substitute minus 1.5 into this complicated equation. So what we can do is we can do 3x cubed plus 2x squared minus 4x plus 7, and press the calc button, and I want my x to be negative 1.5. I get an answer of 59 over 8, so 7.735. So my y value is 7.375, sorry. Okay, so what I'm doing is I'm doing 3 lots of minus 1.5 cubed plus 2 lots of minus 1.5 squared minus 4 lots of minus 1.5. Okay, and students tend to like try and do this mentally in their heads, which is admirable, but you want to be able to check your answer at the end by using that substitution. So you can use this for any equation where you have to substitute a number in and just double check it, like if you're doing table of values and so on. You've got all of that functionality within the calculator there. So hopefully that's been useful to you. A quick whistle stop tour through the calculator, but it's really handy for you. And if you have any questions about how to use any of those functions, then let me know in the comments below. And good luck in your exams.